Good afternoon. Today we are working on the video for packet number 4. This packet is due the Tuesday after Thanksgiving. Tuesday after it's due, but if you turn it in before Thanksgiving, then you'll get to make corrections. My packet on here is an older version, so their pages might be in a different order, or there might be different numbers on some of them, but it'll be the same kind of math that we have to do, so I can explain how to do the pages. First page, Judy listed a fifth. Nope, that's not the right page, is it? Is that the first? Oh, I was thinking of the second page. Okay, Judy listed a fifth number with its set of data of 3, 6, 7, and 10. The number she included made the mean of the 5 numbers equal their median. What number could Judy have included with the data? There's more than one correct answer. So I have one answer written down, but every year I have people who give me different numbers and I go, oh, let me see if that works. Oh, let me see if that works. So there will be different answers that you can come up with. So you might get a different number than one of your friends. As long as it works, you get credit for it. So we have to think, if we have 3, 6, 7, and 10, what does median mean? Middle. So you want the middle number to be the same as the mean. If you add all 5 numbers up and divide it by 5, you'll get the same number of what the median would be when you add that 5th number in. Like I said, there are numerous answers to it. So you just have to figure out what works for you. Yeah, we're not noodling anymore. So it's kind of a check and guess and check. Henry?
I forgot how, if you have 4, then how you find the median.
So if you have 4, you find the middle 2 and you find the average of the middle 2. But we're not going to have 4 for this one. So you don't have to worry about it for this page because we're adding a 5th number. So you need to put a number. Maybe you put a number out here. Maybe you put a number in here. Maybe you put a number here. But you're going to have 5 numbers. So there will be one number in the middle, depending on what number you add to it. Olivia.
I have no idea what I did, but it looks like I got 9.5.
That would not be correct. So it will be a whole number that you are going to add. Okay, a whole number. All right, let's look at our next page. This is the airplane one, right? Yep. On a recent show, thank you to my friends not talking. On a recent airline flight, there was one empty seat for every 3 passengers. So we have 3 passengers, and then we have an empty seat. Then we have 3 passengers, and we have an empty seat. 3 passengers, and an empty seat. We do that for 132 seats. How many passengers were on the flight? What kind of skip counting are we doing it by here? By 4s. Because we have 1 seat, 2 seats, 3 seats, 4 seats. All right? You have 3 passengers and an empty. 3 passengers and an empty. 3 passengers and an empty. So we know we're going by multiples of 4. So if we know there's 132 total, divide down to see how many would be in the first seat. Then we have to know that there are 3 of them. So if we have 132 all together, how many would there be in the first seats? If I divide by those 4 seats, what does that divide down to? 132 divided by the 4 Is that my final answer? No, because there are 3 sets of those. The only hint I'm going to give. We found the 1 set, but there are 3 sets. We're not going to give answers. Do you have a question?
I can't find my card.
I will have to see if I have an extra one. So let me go through this first. What?
Can I see my walker?
Wait until we're done with the videos. The next one is the 5-card challenge. My 5-card challenge here is an old one. Go with the 1 on your packet where you're equaling an ace. An ace is how many? 1. So the ace is a 1. Okay, so you can use the 5 cards on the top, use the different operations to equal a 1. I did have one of your classmates ask me, hey, what is the highest 5-card challenge somebody's gotten? I said, well, I know Aiden Thomas years ago got over 1,000, and then Andrea in 8th grade wanted to beat Aiden Thomas really bad, and she got like 1,300 just this fall. And so our friend said, I don't know if I can do 1,000. And Andrea's in 8th grade. What's the 6th grade record? And I said, oh, that's a great question. I'll ask Mr. Schultz. So I asked Mr. Schultz after school yesterday. I said, hey, do you know what the 6th grade record would be? And he went, gosh, I don't know exactly, but I want to say it's probably getting close to 150. And I said, perfect. So 150 is what I'm throwing out there. Whoever can get 150 for the 5-card challenge, if you get 150 points, you will be the new record holder for 6th grade. And I will announce that to every 6th grade class that, hey, if you want to try to beat, let's say it's Gabe who gets 150. You want to beat Gabe, he's got 150. So your name will be out there, just like I talk about Aiden Thomas, and we're going to talk about Andrea Del Moro, because they've got the high for all of middle school. I'll put your name out there for 6th grade. Did you have a question, Gabe?
I have 82 right now.
Sweet. Yep. Olivia.
Andrea's my mom in the class.
Henry.
So is it just on this 1 sheet?
No, any math packet. If you get, it doesn't matter which math packet it is.
It just has 1 sheet. Can it be all added up?
Yeah.
It has to be equal to 1 using these 5 numbers.
Oh, okay.
So using these 5 numbers, if you can get 150 points. Okay, so you need to get loose leaf to write it on it. Yeah, it has to be from 1 packet. It can't be, oh, I had 20 from that packet, and I had 50 from this packet, and I had, no, it has to be 151 5-card challenge. Okay. All right, next page is our pattern page. So, just double checking that, yep, this is the same page. So it says complete the table through figure 7. So we know figures 1 to 4, and we have to figure out that pattern to go down to 7. So help me fill in what we know about figures 1 to 4. How many blue? How many green?
0.
How many red?
0.
Total. How many blue?
1.
How many green?
5.
How many red?
0.
How many total?
6.
How many blue?
1.
How many green?
5.
How many red?
9.
How many total?
15.
How many blue?
14.
How many red?
5.
How many red, or sorry, how many green, how many red, and how many total? 28. Okay, so we know we've done patterns like this before where it increases every 3rd one. So we've got 3 1s. So what am I gonna need for the 14s? I know I need 3 14s. I've got my 3 5s. I know I need 3 reds. Okay, so that's what I know without really having to think about it. So now I have to think, where do I see a pattern with my total blocks? Henry?
You add, for 1 through 6, you add 5, and then 6 through 15, you add 9, and then
Well, we don't know that, Henry. I don't know how you can jump ahead. We know what this pattern might be, but we don't know a pattern if there's nothing there to prove it.
you add 4 to each number. Like it's 5 when you start, then you add 4, then you get 9. So 6 plus top 9 equals 15. Then you add 4,
Oh,
gets you
so
13.
you added, what do you mean you added 4 to each number?
You
So-
add 4 to that 5.
Okay, so there's 5 here. So this was 9.
And add 13.
And
Oh,
then
I see. So we're going up by 4 each time? Oh, see the pattern I thought, so you would add 17 there?
Yes.
Okay. I found a different pattern.
What was that?
So my pattern that I found was if I look at figure 1, there's a total of 1. So figure 1, I multiplied by 1. Figure 2, I multiplied by 3, right? 2 times 3 is 6. Figure 3, I multiplied by 5.
So you
Figure
add 2
4,
each time.
I multiplied by 7.
You skip all that.
Yeah, skip counting by odd numbers on what we, same thing. You find different patterns. Henry found one pattern, I found a different pattern. So find those patterns. Once you can fill in the total blocks, then we can find that one number that's missing, right? You subtract the 2 we know from the total and you get what's missing. Then, oh, look at that, we'll be able to fill in the next 3. Then we've got 1 missing, so subtract and fill in. And then you've got the 1 missing. All right, next page. My next page is a different page. Switch to this page. Mine are just in a different order. So the figure at the right is a right rectangular pyramid. So how would we draw a net for a right rectangular pyramid? What am I going to put in the middle, Grace? The square, that bottom square. So if I've got this bottom square and I'm cutting it open so each side, each of the faces lays flat. Can you wait till we're done with the video? What is the shape of each side? Triangle. So that's my net. Now I need to label. What is the size of each of my square sides? 8. So each side is an 8. I don't know the length of the sides of the triangles, but I know their height. What is the height of each of my triangles? 16. So that's what I label on here. Now I need to find the surface area. How do I find the surface area again, Jude?
You would multiply, or like try to find the area of each shape in there and then add them all up.
I need to find the area of each shape. So the area of my rectangle we know is length times width. Length times width, I would put that area. 1 square. Area of a triangle. Who remembers the area of the triangle? Kyle?
Isn't it the base times height?
Half of the base times the height. So my base is this right here. My height is that 16. Multiply those together and find what a half is. Divide it by 2. That is your area for each triangle. Then, like Jude said, you have to add all 5 of those sides up to get your surface area. We have feet times feet, so our answer will be in feet squared. Lucas.
You forgot that parentheses.
I didn't forget any parentheses.
One half base times height is going to be 1 half times base times the height. And
Yeah.
base times height.
So ask yourself, does it matter at what point we multiply by a half? Does it matter? If I have 2 times 3 times 5, and I decide, maybe I want to do 3 times 2 times 5, or 5 times 3 times 2, do I get a different answer? They're always the same. So when we're multiplying, we don't need parentheses. I'm not going to say I have to multiply these two first before I multiply that. It doesn't matter. So what that means, my mental math friends, what that means is I could say a half of 8 times 16. I could do that half first and then multiply. In my head, I said, half of 16 I know is 8. 8 times 8, I know that. So I don't have to do 8 times 16 and then divide it by 2. I can turn it into some mental math with numbers I know. So what I did in my head was I did a half of 16 and then I multiplied that by 8. Didn't get the same answer. One way I can do it in my head. The other way I'm going to use my calculator. Does that make sense, Lucas? James.
I just found the answer.
Good. That just gave you the area of a triangle. So then you have to make sure you find the surface area. All right, the next one. We have a right rectangular pyramid. Any guess what this volume is? It is not the same as that triangular prism we did last math packet. This is a pyramid, not a rectangular or a triangular prism. So it will be a different formula. What is the formula for the volume of a right rectangular pyramid, Peyton?
Base times height times width.
Base, or the length,
Length, yeah.
times the height times the width,
And then divided by 3.
divided by 3. 1/3 of the base times the height times the width. Length times height times width. 1/3 of it. So we're going to divide it by 3. So the next step is to put the calculation that we would put into our calculator. So we've got 10 times 8 times 6 divided by 3. That answer goes right there. What is my measurements going to be? That's when I'm done. I'm recording this. What is my measurement going to be, Adeze? Inches what? Not squared, because I'm multiplying 1, 2, 3 inches. Inches cubed. Because I multiplied 3 inches together. So my answer will be in inches cubed. Now, on our packet, remember I said this is an old page. On our packet, it says Pre Algebra. You need to find the, recall that the volume of a pyramid is 1/3 the volume of a cube with the same base. So, with the width and height dimensions. So what is the volume of the cube of that this pyramid was cut from? So look at what this math 6 says. That's actually our pre-algebra. What is the volume of the rectangular prism that this pyramid was cut from? How do we find the volume of a rectangular prism? Think back 3 math packets ago. Lauren. Nope. I want to know how you find the volume of a rectangular prism. What's the formula? So what's the formula, Henry? Length times width times height. That's how we find what the cube is that this was taken from. I'm doing a really bad job drawing my picture, but that pyramid was taken out of this cube. So the length and the width and the height are all the same numbers. It's just we want the full cube that the pyramid was taken from. So we're using the same length, width, and height. Are we going to divide it by 3? No, because we want the cube size. So do length, width, and height to find that rectangular prism. Henry, what's your question?
How do we
Is that 6 the height?
Yep,
Oh, same.
because that's what we used up here, Henry. That's what we used up here. It's the same measurements, length, width, and height, but we're just not dividing it by 3 because we want the full cube size. All right, next page. All right, turn to this page. Turn back to this page in your packet. Perimeter. Perimeter, remember, is the measurements going around the outside. So, easy to add up the 10, the 14, and the 10. But oh my goodness, we have a semicircle up here. How do we find the perimeter of a circle? What do we call the perimeter of a circle? Damien? Circumference. Oh my goodness, this brings us back to our Pre Algebra entrance exam. How do we find the circumference of a circle? Lucas.
Pi r squared.
It could be pi r squared. Nope, that is not circumference, my friend. That's area. Addie, Claire.
Pi times diameter.
We could do pi times the diameter, or remember it's 2 pi r because r is half of the diameter. They gave us a diameter, so we're just going to use the one that has the diameter in it. So if we find pi times our diameter, what do we have to do to it to make it work, Kyle? Yeah, we have half a circle. So we have to divide that by 2 because it's a semicircle. So that will give us this measurement. So we can add that to the 10, the 14, and the 10. Oh. That will give us the perimeter. So find half of the circumference and add the 3 sides of the square. That gives us the perimeter. Now we have to find the area. How do we find the area of a rectangle? Lucas?
Base times height.
Length times width. We don't really have a base when it's a square or a rectangle. We just call it length. Length and width. So we've got the length and the width. That'll be the area of the square or rectangle. How do we find the area of the circle, Lucas?
Area of the circle. Pi r squared.
Pi r squared. So for that r, that's half of my diameter. Okay. So we're going to have pi, what's half of 14?
700.
Pi times 7 squared. What do I have to do because it's a semicircle? Claire? Divide it by 2. That will give me the area of my semicircle. Then I add my 2 areas up to get my area. And my answer for the perimeter will be in just millimeters, but for an area, we do 2. So it's length and width, so it would be millimeters squared. Kaylin.
Oh, I saw my packet from this summer, so I knew what the
Perfect.
measurements were.
Perfect. Lucas.
Let's see, the answer was 2 millimeters. 2 millimeters squared, wouldn't it just be 4 millimeters?
Because if you said 4 millimeters, that's going in one straight line. When we say squared, we know it's going to be in that shape. All right, and because it's not 2 squared millimeters, it's millimeters squared. So we're squaring the measurement, not squaring the number. Does that make sense? All right. Next page, let's see what's the next page on my board. Oh, Pascal's pattern summary. Some patterns with Pascal's triangle. So, on each side, on the left On the left side of each row, write the number of the row. Remember, the very top is 0. So then we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So everybody should have that written down. So now, on the right side of each row, write the sum of the elements. So that's 1. 1, 2. 1 plus 2 plus 1 is 4. 1 plus 3 plus 3 plus 1 is 8. Keep going. Finish that up. Then we have to answer the questions at the bottom. What relationship exists between the sum of any row and the row before it? What's the pattern that you notice as you go down? What is the relationship between the row number and the sum? There is a relationship. It's up to you to find it. I found it. Then we've got the 2 questions underneath that. Shh. Thank you. We've got the 2 questions under it. Following this pattern, so if we know what the pattern is, find row 11, then find row 16. Okay? The polynomial page. My page is different on the board here, but you're going to just do the same polynomials that we always do. And then we have the last page is our logic page. So you have to mark in the table. Larry does not write for, I can't read that. Larry does not write for either making movies or for sightseeing friends. So we have to think to ourselves, what is the topic? So he's not writing for making movies. So he's not writing for which of these topics? Cinema. So Larry's not doing cinema. And he's not doing sightseeing friends. So what would that one be? Travel. So you have to kind of figure out, okay, what is sightseeing friends about? It's about travel. The head writer of Curious Concerts is either Joy or Brian. So who is it not? It's not Rachel or Larry. So Curious Concerts would be which topic? Music. So it can't be Rachel or Larry. Oh, that's helping narrow down some stuff. So that's what we have to do for each of these and figure out who is for each topic. Okay? So keep narrowing it down. It is one of my favorite things too. Any questions? All right, if you're watching this at home and you still can't figure something out, then come and ask me questions. But for those of us that are listening in here right now, first thing you do is you watch the video again. Make sure you're trying to figure out on your own first, and then come ask me if we're still struggling with it, and I will help you. Have a wonderful day.